Welcome students. So, this is the first lecture on sets. First let me define what is a set. So, a set is a well defined collection of objects. A set is a well defined collection of objects, or sometimes we say elements. So, let me explain what do I mean by a well defined collection. So, by well defined, collection we mean that given an element, given an object, we can clearly determine whether the object is in the collection or not. Right. So, let me explain it by example. So, one, the collection of all vowels of the English alphabet. So, what is this collection? So, we have the English alphabet, there are 26 alphabets A to Z, and we know that there are 5 vowels A, E, I, O, U. So, this is a well defined collection. So, given an alphabet, you can tell whether the given alphabet is a vowel or not. So, this is an example of set. This is a set. Second example. So, suppose I say that the collection of best cricketers in the world. So, this is not a well defined collection, because it depends on people's perspective who is a better cricketer. So, this will not be a set. This is not a set. Okay, so, we will see many examples of sets in due course. So, for notations, we shall usually denote sets by capital letters So, example A, B, C, X, Y, etc. And the elements we denote the elements by small letters like A, B, C, X, Y, Z, etc. Another notation so we write A belongs to A, this is read as A belongs to the set capital A, or A is an element of the set A to say A is an element of the set capital A. So, for example, let A be the set of all even natural numbers right, which means that A is the collection of all natural numbers which are divisible by 2. So, then the natural number 2, this is an element of the set A, right. We write 2 belongs to A, but the natural number 3, this is an odd number, not an even natural number. So, 3 is not in the set A. So, for not an element of A, we cross this epsilon. So, now we will see how to represent a set. So, representation of sets. So, there are two ways by which we generally represent a set. First one is called roster or tabular form. So, in this roster form, what we do is that we list down all the elements of the set. So, all elements of the set are listed within this curly braces and separated by commas. So, for example, the set A consisting of all even natural numbers less than or equal to 10 will be represented by A is equal to. So, we just asked what are the elements of this set A. So, we want all the even natural numbers which are less than or equal to 10. So, the smallest such even natural number is 2, then the next one is 4, 6, 8 and 10. Sometimes we have sets which does not contain finite number of elements, then also sometimes we can represent using this roster form. So, for example, the set of all odd natural numbers can be represented by. So, 1 is the smallest odd natural number, then the next one is 3, next one is 5, 7, 9 and then we put dot dot dot. So, if we know a pattern, then we write the first few elements of the set and then we use dot 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 to say that there are infinitely many elements of this set. There is one more way of representing a set normally. So, the second way to represent a set is called the set builder form. So, in this form the set is described by the characteristic property possessed by all the elements of the set. So, for example, if we look at the previous example, the set A is equal to 2, 4, 6, 8, 10. Is represented in set builder form as A is equal to. So, we just write it is a collection of all n such that n is a natural number divisible by 2 and n is less than or equal to 10. Right. So, there can be many different way in which you can write the same set. So, now let me introduce some of the sets that we use in mathematics, some notations which are used. So, we will use this capital N to denote the set of all natural numbers. So, set of all natural numbers is represented by this capital N with one more vertical line here. Similarly, we represent by Z, this is set of all integers. So, this includes positive, negative and 0, all natural numbers. We will denote by Q the set of all rational numbers. Then R will be used for set of all real numbers. So, set of all natural numbers, integers, rational numbers, real numbers. Capital C will denote the set of all complex numbers. And then we can use if I write R plus, this means set of all positive real numbers. Similarly, Q plus will mean set of all positive rationals. So, next thing we will explain what is meant by the empty set. So, the empty set is the set which does not contain any elements. So, the set containing no elements. And the notation used for empty set is this phi, or we use the curly braces without any element inside. The empty set is also called the null set or the void set. So, if you see these terms, they mean the empty set itself. So, for example, I can describe a set, let A equal to so we have already introduced this notation. This means that this is this set containing all n in natural number such that n is bigger than 1 and less than 2. So, suppose we write this set. So, is there any natural number which is bigger than 1 and less than 2? No. So, this set is empty because there is no natural number strictly between 1 and 2. Another example, suppose B is the collection of all x in rational number such that x square is equal to 2. Right. So, you might have seen in high school that there is no rational number whose square is equal to 2. So, this set B is again equal to the empty set. So, let me also use a notation. So, okay, I will come to that later. So, first let me define finite and infinite sets. So, a finite set is a set which contains only finitely many elements. So, the set is called a finite set if it contains only finitely many elements. Otherwise, it is called an infinite set. So, example, the set A, set of all vowels is a finite set, because it contains only 5 elements, but all these examples that I give, set of all natural numbers, set of all integers, rational numbers, real numbers, complex numbers, these are infinite sets. So, next thing we will say what we mean by two sets to be equal. So, two sets A and B are said to be equal if they contain exactly the same elements. So, note that while representing a set, the order of the elements is not important. So, for example, if A is equal to 1, 2, 3 and we write B equal to 2, 3, 1, then A and B are the same set, because both A and B contains the same 3 elements 1, 2 and 3. So, while writing sets, it is not important in which order the elements come. So, next concept is of subsets. So, let X be a set we say that a set capital A is a subset of X, and this will be denoted by A subset of X if every elements of the set A is also an element of the set X. So, this is usually denoted as A subset of X if A belonging to capital A, this should imply that A is also an element of capital X. So, some examples of subsets of the sets that we have seen. So, note that the set of natural number, this is a subset of set of all integers, right. Every natural number is also an integer. The set of integer is a subset of set of rational numbers, which is a subset of the set of real numbers, which includes rationals as well as irrational numbers. And then once you learn complex numbers, you will see that real numbers are subsets of complex numbers. Now, one important point is that two sets A and B are equal if and only if A is a subset of B and B is a subset of A, right. So, A is equal to B, this is equivalent to A subset of B and B subset of A, right. So, this is very simple thing to see that because two sets are equal if they contain the same element. So, every element in A must be in B and vice versa. So, A is a subset of B and B is a subset of A. but this is very useful when you try to prove that two sets are same, you prove that each is the subset of the other one. There is another concept called power sets. So, given a set A, the power set of A is the collection of all subsets of A, and the notation used for power set is P of A denotes the power set of A. So, P of A, this will consist of all B such that B is a subset of A. So, suppose A is equal to 1, 2, 3. A consists these 3 elements 1, 2, 3. Can you write down what is the power set of A? So, first of all, empty set is a subset of every set. So, empty set is in the power set. Then we list down all the sets which contains all subsets of A which contains only one element. So, we have this set 1, the set containing 2, the set containing 3. So, we got all the sets containing 0 element, then all the sets containing 1 element, then you can list down all the sets which contains 2 elements. So, we have 1 2, 2 3, 1 3, and then all the sets containing 3 elements, we have 1 2 3. Right. So, this gives me all the subsets of this set A containing 3 elements 1 2 3. Now, if you count how many elements are there. So, here the number of elements in the power set is equal to 8, which is equal to 2 cube. So, for a set A, we denote by this will denote the number of elements in A. So, if we have a set A containing n elements, then the number of elements in power set of A, this is always 2 to the power n. Why is this? So, this is exactly like we did for the special example containing 3 elements, that when you are looking at the subsets. So, if B is any subset of A, then any particular element of A is either in B or it is not in B, right. So, there are n elements and for each we get a subset by specifying whether it is in B or not. So, therefore, we have two choices for each n elements and hence the number of such subsets will be 2 to the n. So, this kind of counting you will also learn when you learn permutation and combination. So, now we will learn some operations on sets. So, the first one is called union. So, given two sets A and B, the union of A and B this is denoted by A U B consists of all the elements which are either in A or in B. And note that when we say something is either in A or in B, it also includes elements which are in both A and B. Right. So, let me write this notation. So, A union B is the set of all x such that x belongs to A or x belongs to B. So, for example, let A be the set containing 1, 2 and 3, BV the set containing 2, 3, 4 and 5. Then A union B, it must contain all the elements of A and all the elements of B. So, we write 1, 2, 3 and then we have 4 and 5. So, maybe you should note that while representing a set, we do not repeat the elements. For this example, you see 2 and 3 are occurring in both A and B, but when we write A union V, we do not write 2 twice or 3 twice. So, another basic operation on set is intersection. So, if I have A and B are two sets, then A intersection B, this consists of all the elements all x such that x belongs to A and x belongs to B. Right. So, intersection this consists of all elements which are common to A and B. So, for the previous example, A is equal to 1, 2, 3 and B is 2, 3, 4, 5. When we write A intersection B, we look at all the elements which are in both A and B. 1 is in A, but not in B. So, 1 is not in A intersection B. 2 is in both A and B. So, 2 is in the intersection. 3 is again in both A and B. So, 3 is also in the intersection. Then 4 and 5 are not in A. So, A intersection B consists of only these two elements 2 and 3. A intersection B is the empty set, then we say that A and B are disjoint. So, the next operation on set is the set difference. So, the notation is this or simply A minus B. So, what does this mean? So, the set difference of A and B consists of all the elements which are in A, but not in B. A minus B, this is equal to all x such that x belongs to A and x is not in B. Okay. So, for example, A equal to 1, 2, 3, B is 2, 3, 4, 5. then A minus B, we have to look at all the elements of A which is not in B. So, 1 is in A and not in B, 2 and 3 are in A, but they are in B also. So, we do not include this in the set difference. Similarly, if you write B minus A, you have to write down all the elements of B which are not in A. So, 2 and 3 are in A, but 4 and 5 are not in A. So, B minus A consists of 4 and 5. So, note that I can write A union B is equal to A minus B union A intersection B, union with B minus A, right. So, let me explain this by a Venn diagram. So, if we have this as the set A and this is set B, then A minus B consists of all the elements A in A which is not in B. So, that means that this is A minus B, this one is A intersection B, and this is B minus A. So, this is A minus B, this part is A intersection B, and this one is B minus A. So, you can see that A union B can be written as these unions, and note that here the unions are disjoint. So, there is no intersection between these three parts A minus B, A intersection B and B minus A. So, this one here is disjoint union. So, this is something important again. To write the union of sets, we can write as union of disjoint sets by using this set difference and intersection. Some other terminology. So, singleton sets, this means set containing only one element. So, the set containing only 1, set containing only 0, the set containing only the alphabet A, these are singleton sets. Let me also introduce what is called complement of a set. So, let U be an universal set and A be a subset of U. The complement of A in U is, so this is denoted by A prime, this is equal to all the elements which are in U, but not in A. complement of A consists of all elements which are not in A. So, to say complement, we always have a bigger set and a subset, and then complement is with respect to that bigger set which we call the universal set. So, for example, if U is 1, 2, 3, 4 and A is the set containing 2 and 3, and A complement is equal to the set containing 1 and 4. Right. This is U minus the set A, set difference with set A. So, we will stop here. In the next class, we will discuss some more properties of sets, and then we will also look at some of the problems from the exercise. Thank you.